All right, so in this chapter section on angles and angle measurements, we're now going to explore something called arc length. And an arc length is formed by a central angle on the circle with a vertex at the center of the circle. So here we got a vertex at the center of the circle. We've got this central angle here that we're calling theta, and it's going to be in radians. And if we know the measure of the central angle and the radius of the circle, we can find what is called the length of the arc that is intercepted by the angle. And so our arc is up here. And so we're looking at something called the arc length. So again, if we know the measure of the central angle, and if we know the measure of the radius, then we can determine this arc length, such as this. And so we have a formula here that the arc length represented by the small letter s is equal to the radius times theta. And this theta is given to us in radians. And so sometimes we got to convert from degrees to radians in order to determine the arc length. So we're looking for the length of the arc that is intercepted by the angle when we have this a central angle and the radius of a circle. So let's explore exactly what we're talking about here over on the next slide. We're going to find the arc length. All right, so here we're told that a circle has a diameter of 9 centimeters and an arc length, or find the arc length if the central angle is 60 degrees, and we're going to round it to the nearest tenth. All right, so we've got a diameter of 9 centimeters, and we've got a central angle of 60 degrees. And before we can solve this particular problem, we got to do a couple of conversions. We've got to convert this diameter into radius, and we've got to convert this central angle from degrees into radians. Well, converting the diameter into a radius is pretty simple. We just take the 9 divided by 2, and that equals 4.5. So our radius of this circle is 4.5. And we've got a central angle of 60 degrees. And we just explored how we would convert from degrees, from degrees to radians. And we would multiply this 60 degrees times the conversion ratio of pi over 180 degrees. Okay, so let's see. Well, I can do a little cross cancellation here, and 60 will go into 83 times. So my central angle then is equal to pi over 3. Remember now, we got a little formula. The arc length is equal to, represented by this s, the radius times theta in radians. Why did I put pi over 6 over here? I have no idea. It's pi over 3. Pi over 3. All right. So let's just then substitute in. We're going to find the arc length. And this arc length is equal to our radius, which is 4.5, times pi over 3. And I think perhaps I should include the calculator here to do this calculation. I can tell you that it's going to be equal to 4.7 centimeters. But we're going to jump over here to the calculator and finish this thing up. How about that? All right, well, here we are. We're over in our calculator, and we had taken that 9 centimeter diameter and converted it into a radius. That makes that 4.5, 9 divided by 2, 4.5. And we're going to multiply it by pi over 3, where we converted our 60-degree central angle to radians. And I'm going to put that in parentheses. Now, my pi button is right here above where the little caret is. I'm going to hit second pi divided by 3, close my parentheses, hit enter, and shazam, if I'm rounding this to the nearest tenth, yes, I'm rounding this to the nearest tenth, then my arc length is 4.7 centimeters, which is what I believe we indicated on the previous slide. Your parentheses is your friend on your calculator. All right, well, there we go. Finding an arc length when we know the central angle and the radius on a circle.